So let's look at unit or note 6. Some of it is going to be reviewed from yesterday. Guys, listen up. Some of it's going to be reviewed from yesterday. Some of it's going to be new stuff. So you don't need to be on your computer right now. Just have it to the side. We'll work with it in a second. Okay, first question we're looking at. The first example I have. So let's look. We are looking kind of like we talked about yesterday, except it's going to be a little harder. So note 6. First thing, Kinder likes to watch crime scene investigation shows on television. She watched a show where investigators used a shoe print to help identify a suspect in a case. She wondered if it was really possible to predict how tall someone is from a shoe print. To investigate, she collected data on shoe length in inches and height in inches from 10 adult men. Her data appears in the table and scatter plot below. So kind of like we talked about yesterday, we have a table. We graphed the table. She graphed it. She has a data plot. We talked about yesterday what kind of the trend line looked to be. So what type of correlation or what type of association does this seem to have? Do what? It's not super strong correlation. They're not all clumped together. So it's not a strong correlation. But if you look at it, it tends to have what type of association? Positive. It's not strong positive, but it seems to be kind of going uphill. Linear or non-linear? Kind of linear. It's not super strong linear, but it kind of has that kind of straight line path sort of ish. Okay? So if it wants to describe a scatter plot using how are things associated, linear non-linear, strong positive, positive negative, and then like strong and weak. This would be considered weak because the points are spread out. They're not all clumped together. Okay? So part 1, we're going to draw a trend line for the data and write the equation. These two kind of go together. We're going to kind of do the two questions together, but I want you to draw a trend line. So trend line is basically about the same as the line of best fit. So what we're going to do, we're going to try to draw a line that's in the middle. So I'm going to pick this to be somewhere like, let me kind of see what I want. Where I want. It is going to kind of be above these 2 points and kind of in the middle. So something like this. So it's kind of above those 2 points, something like this. It won't be perfect, but it will be close enough. So something like this. Okay, I'm drawing a trend line. Trend line and line of best fit are basically the same thing. So I'm trying to get a line that is in the middle of my data points. Now, as I look at this, we talked about yesterday how to do the slope and y-intercept. We did that yesterday with the trend line, slope and y-intercept. Now, the issue with this, if I look at my y-intercept, this is going to be off because we have these little squiggly lines down here. So this one's going to be hard to just look at it and do the y-intercept because if I look, those squiggly lines mean that I skip numbers. That's going to kind of screw up my graph. So because I have those squiggly lines, I don't want to draw the line all the way through because my y-intercept is going to be off because I'm skipping some points at the beginning. That's what those lines mean. Like I skip from 0 to 11.25 and then I skip from 0 to 65. So it's going to be hard to get the slope of this equation because the y-intercept is going to be off because of those lines. So what we're going to use to find the equation is we are going to write the equation and we are going to use, now on the homework and on the test it's going to say something like use linear regression. Basically what that means is if it's not easy to find the y-intercept and the slope, like in this case, we can use our calculator, Desmos, to find the equation of the line. And that's what we're going to do now. So if it might say use linear equation, it'll say use the regression on your calculator. We'll look at it on the homework. But you'll be able to tell when I want you to be able to use your Desmos. So that sheet I gave you, finding the line of best fit using Desmos.com, that gives you a step-by-step direction. So go ahead and get your device out. Let me pull up mine real quick. and then I will kind of walk you through this. Okay. See if I can get this working. Austin, Andrea, Callie. Attendance office right now.
Okay.
Uh-oh, you guys are in trouble.
Probably not. Oh, probably are.
Okay.
Let's see attendance office.
Okay.
Okay.
Okay, so let's look at this. You're going to go to desmos.com, D-E-S-M-O-S, it's on the sheet. So you're going to go to Desmos, D-E-S-M-O-S. The sheet is very straightforward. Now if you look at this, we are going to click on the big red button that says Start Graphing.
I'm waiting on my computer to turn on.
Okay, something like this. Okay, what we're going to do, we are going to draw the table from the example they give us. So we are going to enter in the table that they give us with the shoe length and height. So to do that, number 3, click on the square button in the top left of the screen. Let me make mine full screen. Okay, so you're going to click in the top left button that has a plus on it. This is the Add Item button. And you are going to click on the third option down that says the table. So we are going to add a table. And we are going to type in the table that they give us on that first page of the notes, the shoe length and height table. Let's go ahead and start with the X values. So 12.6, enter 11.8. If you press enter, it will enter in a new one. And you will see numbers start appearing. It tries to predict the numbers. You can just type over it. 12.2, 11.6, 12.2, 11.4, 12.8, 12.2, 12.6. I made a mistake here.
Hey, how do you get it to look like that?
It's on the sheet. Up in the top left, the Add Item button, and you click the table. So 12.2, 12.6, 11.8. There are 12 of them, 10 of them. 10, 5, 6, 7, 8, 9, 10. 10 of them. Okay? Now my Y values, you're going to go through and enter in your Y values still. And you just are going to go 74, 65, 71, 67, 69, 68, 70, 69, 72, 71. Okay? So if you just got here, we're in desmos.com. The sheet has step-by-step directions. Kevin, why are you sitting right in front of her? Okay, so you're going to go up here to the plus table and then enter in the table from that first front page. Now you may not see your scatter plot because it's zoomed in at the origin, so you may have to move around a little bit to get to the actual points. But if you zoom out, you can see they're all up there. I don't care too much about what it looks like. It might look a little weird, but that's okay, as long as we have the table in. Okay, and you can keep moving on if you want to by following the directions. Number 5, click on the square button again in the top left corner, the plus button, and we are going to add on the first option down, which says expression. So we're going to add the first item down, and we are going to add an expression this time, and it will bump. Huh? You have to zoom out. Zoom out so you can see the actual point, because the point is. Does that make sense? And then go up to the add button, and we're going to add an expression, and it should put in another line underneath here. Okay, and then on the top of the back page.
Wait, how do you enter you have all this stuff right here, right?
Yes.
It's automatically entered?
Yeah.
Alright.
Yeah. And then go back up to the plus on the top left, add expression, which is the first one down. And you are...
But I put it at number 1 and move back.
It doesn't matter.
Alright.
It doesn't matter where it's at, what order that is. In your top of this back page, you're going to type this on the line that appears. So Y1, you're just going to type Y1, and when you type Y1, it will automatically bring the 1, make it a subset. So you're going to type Y1, and it will automatically bring the 1 down. You're going to type, it's not an equal sign, it's a little tilde symbol. That tilde symbol on the Chromebook comes from pushing Shift and the button left of the 1. So if you look for the tilde symbol, it's going to be the Shift, and the button left of 1. The button underneath Escape on the left. That will give you the tilde button. If you don't have a Chromebook, you can get the tilde button by going to Function, Function, Stat, and then it's right here in the middle. So if you have a Chromebook, Shift, and then the button underneath the Escape button. If you don't have a Chromebook, as it's not, you don't have a Chromebook, some computers don't have it, you have to go to Function, Stat, and then the little tilde button. And then MX1 plus B. And what you're telling Desmos to do is you're telling it to create a line of best fit or a trend line is basically what you're telling it to do. And what you're entering in is you're entering in Y equals MX plus B. But it's just in code so that it knows how to read it. Any questions on that? Now as I look at this, this will tell me, if you scroll down, if you look at what it gives it to you, number 7, this is what the box should look like. Okay, and it tells you the information for the line. So when you type this, it should automatically put a line of best fit, and it's going to tell you information about the line of best fit or the trend line. It's the same thing. As I look at this, it tells you the only ones we'll talk about R in a second, but the M and the V are what I'm really worried about that. It gives you the slope and the line intercept. So if I look at writing my equation, it's going to be Y equals M. So 3 point, just round it a couple places, 3.66 is fine. So Y equals M X plus V, which is 25.28. So once you get that in, it's going to tell you the M slope and the Y intercept.
What step do we write this down?
It's not a step. We'll get to that in a second. Okay? Anyone need help? Some of it, but yes.
Is that the equation?
Yeah, we'll get to that in a second though. I want to make sure Desmos is working for people.
What's the answer?
Patience. Okay, so this is the equation of the trend line or the line of best fit. Should be that same thing. Then you're typed in a data point wrong somewhere. This is what you should see on Desmos. Anybody need help with this?
Oh, I see.
Is it the same? Is your equation same?
Yours did more than yours.
Yeah, I don't care what it looks like.
No.
It should be, then check the data points.
Wait. The E should be 25.2769.
Check your data points. Unless I made a mistake, but
Yeah.
I usually don't.
That was too fun.
Any questions on this? Okay, this will save you a ton of time as opposed to doing it by hand, which I'm okay with. We could do it by hand. We've already done it by hand, but I'm okay with using this. You will be, guys, stop. You will be able to use this on the test tomorrow, and I'll explain what that will look like tomorrow. You'll have to. I'll make sure you.
So we can use our Chromebooks on the test?
No, for this question you can. You'll get it out when you're working on this question. But so as I look at this. As I look at your notes ask, what is the equation for the trend line? Now, the ones we did yesterday were easy to find the slope and y-intercepts. This one is not going to be. Hey, let me give this to you before I forget. Here's this key. You did too? Okay. Friday, I don't know, but just so you have it. Okay, so if I go back to my notes, it wants me to write the equation. Okay, what we basically did, it's the question 2 is the same thing. Okay, so when it says to write the equation, you're going to write the equation we got. So y equals 3.66x plus, what was it, 25 point what?
25.2769.
276, so 28. That is your equation, y equals mx plus b. It looks like a line because it is the line of best fit. So it's going to have that y equals mx plus b form. Okay? And part 2 is basically we found the linear regression. Okay, so it's basically the same thing.
And why did you write your 8 like that?
Because I wanted to? I don't know. Okay. Any questions? Okay, flip it to the next page. Okay, let's look at the next one. Okay, Kendra thought that... Guys, please stop. I'm literally in the middle of talking. Please do not talk over me. So Kendra thought that the relationship between shoe length and height might be different for men and women. To investigate, she also collected data on shoe length in inches and height in inches for 12 women. There's the data in a table. Does it look like there is a relationship between shoe length and height for these 12 women? So as I look at my table, does there seem to be a relationship between the shoe length and height?
Yes.
Okay. Yes is what we're saying. Why would it be yes?
Does it increase as the shoe length?
Okay. As the shoe length increases, it's in order, so it's easier to see. As the shoe length increases, what tends to happen with my height? It increases. Now, this isn't true for every single point, but for the most part, we are going to see it increasing. So yes, because in general, which means not all the time, but usually, in general, as the shoe length increases, you just put an arrow. As the shoe length increases, so does the height. Okay? So we don't necessarily need to be on the computer right now writing this down, please. We'll get back to it in a second. So yes, there is a relationship. In general, as the shoe length increases, so does the height. So what do we think this, we'll just talk about this. What do we think the relationship will be on this, like we talked about yesterday? We don't have a scatter plot drawn, but what relationship or what association do we think my scatter plot will have? It may be strong. Strong is hard to tell because it's hard to see if they're really close together. But it is going to be positive because it's increasing. So as my shoe length increases, so does my height. So I think it's going to be positive. It's harder to tell whether it's strong or weak because it's hard to see if they're clumped together. But we're thinking it's going to be positive. Okay, part B. Use the statistical features of your calculator. That's kind of telling you, okay, use Desmos. Use the statistical feature of your calculator to construct a scatter plot and fit a linear function to the data. Collect and interpret the correlation coefficient. Okay, so let's go ahead, do what you just did. The correlation coefficient we'll talk about in a second, but do what we just did on Desmos. Type in the table, create a scatter plot, and then find the line of best fit. Okay, so get on Desmos and do like we just got done doing. Real quick. So try it on your own. Yep, just if you look in the top right corner, there's boxes. Like if you look at Desmos, there's boxes up here. You can just like those X's will just clear out. You can do the same thing. So try it on your own real quick. What are we expecting since it looks like it's a positive relationship from the table, we're expecting my slope to be what? What do we expect my slope to be if it looks like it's a positive correlation? Positive. So just FYI. Okay, so get the table set up. Okay, you should see that as you type in the points, they're going to start graphing them. You may have to zoom in or out to see a nice, but they're there.
I got him.
Okay, and then the expression, which doesn't change whether it puts it top and bottom, it doesn't matter. Then okay, we get this, and that will help you answer the part B. So as I look at part B, it's going to ask, construct a scatter plot, fit a line function, calculate and interpret. So let's go ahead and write down the equation for part B. Yes? Do it. It's y1, like it says on there. You just do y1 tilde, which is from the shift up there, mx1 plus b. When you just type in y1, it will automatically make the one a subset. And then it will automatically do it. Okay, so let's look at this. Let's answer some questions on this. So if I look at part B, I want to enter in this. So what does it look like my equation is for this? Okay, y equals 3.15, let's round to 2, so 3.15x plus 32.68. Okay, so it tells you your m, it tells you your b, plug it in. We could do it by hand if we wanted to, but this is a lot easier. Now as I look at this, I want to interpret the correlation coefficient. What that correlation coefficient, that is my R value. So if you look at the box that it gives you M and B on the bottom of it, and then it tells you R and R squared. That correlation coefficient is my R value. What does it tell me the R value is? 0.9061. It tells you R, which is the correlation coefficient, is 0.9061. What that tells me is the closer to 1 that is, the higher the correlation. So that tells me, now if you look at your line of best fit, you might need to zoom in a little bit. Does it look like most of your points are close to the line of best fit? So is the correlation going to be high or low? High, because it looks like they're clumped close to the line of best fit. The higher, guys, the higher to 1 the R value is, the closer your points are going to be. So your correlation is close because this is 0.9061. So it's close to 1. So high correlation. And a high correlation, like we talked about yesterday, mean your points are going to be clumped closer to the line of best fit, which it looks like on Desmos. Okay, questions on that? Okay, let's look at C. Suppose that these 12 women can be considered a representative of adult women in general. Based on linear regression, which is the equation we just found, what would you predict for the height of a woman whose shoe length is 10.5 inches? So using this equation I just found, y equals 3.15x plus 32.68, what would I predict for the height of a woman whose shoe length is 10.5? How do I use this equation to predict the height? Well, what variable represents height? Look at your table. Y. So if I want to know if I want to predict the height, I want to know Y. They tell me the shoe length is 10.5, and what does shoe length represent? X. So I'm going to take 10.5 and plug it in for x. Look at what they're asking. I want to know what is the height, which is the y value. What is the y value when the shoe length, which was x, is 10.5. So I plug 10.5 in for x. Don't overthink this. So look at what they're asking for and look at what variable. I want to know height, that is y. They give me the shoe length, which is x, so I plug that in. Now let's use common sense. You can use your table. Look at your table. What am I expecting my height to be about if I look at my table? 66. If I have a shoe length of 10.5, I'm expecting it to be about 66. So let's see. 3.15 times 10.5 plus 32.68. It's 65.75. So it's close to 65.75, which is pretty close to 66. And that is in inches. That is the height of the woman. And it should always make sense. 65.75 makes sense with the table. Okay? Okay. Any questions on that? Okay. Let's go ahead and look at let's look at E. Let's flip to the next page. We'll skip D. Let's look at E. If I look at E, provide an interpretation of the slope of the linear regression. We talked about what slope represents. The slope was what? 3.15, right? What do we got? 3.15. The slope was 3.15. What does that mean? We talked about this some yesterday. Yep. Slope is always what? We talked about yesterday. Well, but in this case, rise is what? Look at your table. What did the rise, when I rise, what does that represent? The change in the what? Look at your table. If you tell me rise over run, what does rise represent? Rise represents x or y axis. If I'm rising up a graph, is that the y? And so rise represents the y, that's the height. So that's the change in height per change in the shoe length. And it's always per one shoe length. So that is the height increases by 3.15, make sure you label it, 3.15 what? Inches per let me say it this way, per increase in shoe length. Let me be a little more specific on that, sorry. Height increases by 3.15 inches per 1 inch increase in shoe length. Because slope is always per a single thing, per one thing. So that is a height increase of 3.15 inches per 1 inch increase in the shoe length. Slope is always per one thing. Okay. Let's look at I real quick. Let's skip down to I. Let's look at I. Would it be possible to use the equation to predict the shoe size of a woman who is 50 inches tall? If so, what would her predicted shoe size be? Let's think about it. I want to know her shoe size, so I want to know what variable. I want to know shoe size, so I want to know what variable. Look at your table. I want to know shoe size. I want to know shoe size, so I want to know what variable. X. So if I look at my equation, right, but I think you're just kind of saying, I want to make sure people knew it. As I look at my equation, it's 3.15 plus 32.86. I want to know, would it be possible to use the equation for a woman who is 50 inches? Well, if you look at your table, it's 50 inches kind of in the table. No, it's a little lower, but we still may be able to do it. Let's see if it works. Okay, so I want to know the shoe size, so I want to find what variable, x or y? X. They tell me y is what? 50. That is the height. 50 inches tall. So I'm going to plug 50 in for y. And I'm going to solve this equation for x. So if I want to solve this equation for x, just because it's decimal, who cares? Get over it. You'll be fine. How do I solve this for x? Subtract 32.68. Okay, use a calculator. 50 minus 32.68. What is it? 17.32 equals 3.15x. How do I find x? Okay, so 17.32 divided by 3.15. 5.5 is 5, round it. So that is 5.5 inches, which makes sense. A shoe length of 5.5 inches makes sense. Okay. Now, real quick, in the homework, it's going to ask if this is an extrapolation or interpolation. So, I'll write these words. We'll talk about it in a second. This is an extrapolation. Okay, because if I look at it, so this is, we want to see if it's in my table or not. This is 50 inches and a shoe size of 5.5 inches. Is this data within the table they give me? No. 50 inches for a height is lower than the table, so that's why it's an extrapolation, because it is not in the given data. That's why it's an extrapolation, because 50 inches is lower than the data they give me. Interpolation would mean that it is inside the data they give me. Okay, let's look at A real quick, and then we'll be done. Next page at A. Okay, if I look at this one, now, if I look at this graph, I want to know, George is 35 years old, what is his approximate heart rate? So we kind of talked about this yesterday with the heart rate and the age. As the age went up, my heart rate went down. So I have a line of best fit. Do I need to use Desmos to find this line of best fit? No, because it hits nicely. You can look at it and find the y-intercept. You can look at it, it hits 2 points nicely, so we can find the slope. So you do not have to use Desmos for all of them like we talked about yesterday. If it hits it nicely, guys pay attention please. If it hits it nicely, you can be able to just look at it. So let's find my slope. Okay, if I look at this, the slope of the line of best fit, look at your 2 points it hits. I go down, how many? 10. No, look at your -5. I go down 5 and I go over 10. And we kind of looked at this yesterday. That's a -0.5. So I think we did the same equation yesterday. So my slope is a -0.5. What's my y-intercept? So my equation would be y equals -1/2x plus 140. Now let's use that equation. We did that equation yesterday. Same one. Let's use that equation to figure out what they're asking. George is 35 years old. What is his approximate heart rate? If I want to know his heart rate, what variable am I looking for? Look at your graph. Y is my heart rate. So I'm looking for my y variable. They give me his age, and what variable represented the age? X. So I'm going to do what with 35? Yep, plug in 35. Look at what each one represents. So plug in 35 for x, and then let's type this in your calculator. 35 times 1/2 is -17.5 plus 140. So negative 17.5 plus 140 is 122.5. And that is BPMs, beats per minute. And I want to know, is this, it makes sense, look at your data, 122.5 beats per minute if he is 35. So if you go to 35, 122, yeah, it kind of makes sense. It looks like it's close to the line of best fit. And I want to know, is this an interpolation or an extrapolation? Well, look and see if it's in the data. So 35, 122.5, does it look like it's in with this data?
Yeah.
Yes. 35, 122.5 would be somewhere like right there, and it looks like it is in kind of the data they give me. So it's interpolation because it lies in the data set. So it's not out kind of by itself. It's not a outlier like we talked about yesterday. It's kind of in with the data set. So it's interpolation. Okay, any questions on this? Once again, not super hard math, just kind of knowing how to use this stuff. Okay, so if you look at the homework packet,